Hello, everyone. Thank you for coming. My name is Jin, and I'm the co-founder of Saga. And today I want to talk a little bit about the magic of horizontal scalability and what kinds of things you can get done once you start developing applications in a more horizontal fashion. And one of the things that you can get from this kind of architecture ultimately is you can get potentially, quote unquote, infinite performance essentially from your applications. And so let's first talk about the history of horizontal scalability, because this has happened in the compute space a long time ago. And the behaviors and the things that we can learn from scaling applications horizontally can be applied to Web3 as well. So let's kind of start with how horizontal scalability came into the compute space. So in the beginning, if you take a look at most kind of compute platforms, there was one CPU, one core essentially, and different applications that were mostly single-threaded competed for the same resource essentially. So this is pre-2005 when processors essentially had a single core. And so most application developers were developing their applications in a single-threaded fashion, right? So these individual single-threaded applications were competing for that single fixed resource. And the single application performance was kind of limited by the performance of that processor ultimately. And there were lots and lots of congestion issues with multiple applications because they were all trying to compete for a singular resource. Now going forward, in about 2005, Intel and AMD and these kinds of new chip developers came up with multi-core, and they started building essentially processors with more than one cores in them. And in the beginning, the developers didn't really know how to optimize their software for that. So what they did is they just took the same applications that they had during the single core time periods, and they just put it in the multiple cores. So essentially now applications were competing for multiple fixed resources. Now, instead of one, there were two cores, which is great. And so congestion kind of decreased, but it was mostly limited because the actual performance of each of the applications was still bound by the performance of that singular core, right? And congestion still kind of exists because let's say you go from one core to two core, and in the past you had 4 applications running. But if you just have 8 applications running now and trying to like stick all these applications into 2 different cores, you still run into the exact same congestion issues that essentially you had. So over time, what developers did is they figured out, we need to do a little bit better, and we need to change actually the software that we're writing to be able to support this kind of new infrastructure, right? So essentially what application developers did is they multi-threaded their applications. So their singular apps were now threaded. So they divided their applications into kind of smaller chunks that could be sent into different processors. And essentially now, instead of one application competing for fixed resources, it was multiple threads within each applications that are now competing for these fixed resources. And it was great because single application performance increased with the number of kind of cores that existed. So over time, processor developers essentially started building 2-core, 4-core, kind of more cores into the system that can make things a little bit faster. However, one of the problems that exist here is that adding cores is essentially something, it's a very long process. It took many years for a quad core to come out after dual core to come out, et cetera. And so congestion still kind of existed in this space because adding cores was not something that was kind of difficult to do. So now, what happened afterwards? We got what we call kind of new infrastructure, right? So from the multi-core stage, first it was, hey, let's deploy these single-threaded applications. Then developers had a paradigm shift in their development where they started threading their applications. And now what they had access to was called elastic scaling solutions, like cloud solutions like AWS, Google Cloud. It essentially allows you to borrow as many cores as you want arbitrarily. And then what you can do is then now your application can start throwing these threads into kind of a dynamic number of cores across all these different systems. So you really didn't have congestion anymore, which was really great. So single application performance can kind of scale almost infinitely now at the limit of essentially the capacity of AWS or these kind of cloud solutions. And you can stand up compute like on demand, which is a behavior essentially that helped developers get into these scalable solutions for their applications. So why am I talking about this, right? Let's talk about where we are in Web3. So in this kind of context of things, if you think a little bit about how the evolution of going from single-threaded to multi-threaded to elastic scaling happened, the same thing is going to happen in Web3. So if you take a look, this is kind of where we were at, I would say, about 2 years ago, where most people were developing on these monolithic chains. So there are these, what I would consider single-threaded applications, single applications that are getting deployed onto these monolithic chains like Ethereum, Solana, Polygon. And these applications are competing for a single fixed resource, right? And we all saw kind of during these other bull cycles that these applications started the gas cost and the performance issues started being pretty obvious because all these single-threaded applications are trying to share this monolithic chain, right? And single app performance essentially is capped by the performance of the single chain. So you can never develop a smart contract that can be faster than the capacity of that single chain, essentially. And there, as mentioned, there's congestion issues with multiple applications that are coming in and trying to share the same chain kind of infrastructure ultimately. So now, where are we right now, right? Kind of in 2023, middle of it. We're kind of in this early stages of multi-chain, and it's kind of the same story. So now we have more than one chain that people can go to. So let's say I'm an EVM developer. I can deploy my application in Ethereum. I can deploy my application in Polygon. And really, but the application developers really haven't really figured out how to take advantage of this multi-chain situation. So to this day, most EVM developers just take the same smart contracts that were kind of deployed on a singular chain, and they deploy it on multiple chains, right? So now the applications are competing for now multiple fixed resources, right? Multiple fixed chains. And the single application performance is still capped by the capacity of each chain. And adding each chain actually reduces congestion, but you still run into the same congestion issue once you increase the number of applications or if there's more things required for each of the applications. So that's where we are today. And if you kind of take a look at what happened in the Web 2 world, you're going to see what's going to happen in Web 3. So what's next for Web 3? Essentially, we're going to have to go through the same developer paradigm shift where people develop applications in a more multi-threaded way. So the traditional kind of application that people are thinking about is not going to kind of go to only one chain. It's going to go to multiple chains kind of in parallel. And different operations that you have with each chain is going to essentially start getting spread out into different chains and start planning around that essentially. So now instead of having one kind of blockchain application that is competing for multiple fixed resources, kind of small threads within each applications are going to start competing for fixed resources. So some will go to maybe Ethereum, some will go to Polygon depending on capacity. And single application performance then now can scale across as there are more chains essentially to start deploying across. And you can actually start scaling your application much more than the capacity of a single chain. And adding chains kind of decreases congestion, as mentioned. It's kind of the same situation as before, but congestion still exists, right? And so because it's very difficult to stand up these chains, it's not going to be as if I can add infinite numbers of chains into the future to get as much capacity as we want. And so now what's going to happen is we're going to get to a space where we need elastic scaling for infrastructure ultimately. And this is kind of the end state of what Web3 infrastructure will be, where developers can stand up chains kind of on demand. So let's say I have an application that I've been spreading across multiple chains, and suddenly it gets even more popular. What you want to do is you want to get to a point where you can stand up chains on demand. Then single app chains can kind of scale almost infinitely because you can kind of push up transactions across all these different chains. And you can actually get rid of congestion altogether. And so you don't have to worry about the capacity of like kind of your applications at the end of the day. So I just talked about how horizontal paradigm shift essentially leads to elastic scaling, and this is kind of what the future of Web3 will be. So let's talk about how this happens kind of in the Web 2 world, when people kind of started doing multi-threaded programming, and then I'll start talking a little bit more about how this will be functional in the Web 3 space as well. So on the top here kind of shows you, let's say, a single-threaded application that you can kind of segment into 8 different parts. In the past, what you did is you develop applications that all run in series. So you would have to run the first one, then the second one, then the third one, then the fourth, and everything has to kind of run serially. When multi-threading kind of happened, what people figured out is you can kind of segment a lot of these use cases into these individual chunks that you can spread across all these different cores, and you can kind of run them in parallel. So on the bottom now is more of a horizontal application. So you have a controller application essentially that schedules the different operations 1 through 8 essentially across these 4 cores, right? And then when those 4 cores are done computing these things and doing things, there's a cleanup step that comes back essentially to the application to make sure that they gather everything and compact it back into a state that you need. And so now what you can do is add elastic scalability. So in the previous slide, essentially, there's 4 cores that exist that kind of just exist in permanence, but you don't have any, let's say that in the example where there's 8 of these operations, you can kind of spread this out. But let's say now the operations is there's like maybe 100,000 different things that you have to do. If you divide that by 4, there's still a lot of things that are going into each of the cores. So the next step is elastic scalability, where you can kind of manually spin up as many of these chains on the left side as possible, and that gets kind of included into your process flow of your actual application, right? So as demand comes, let's say, as previously mentioned, there's 100,000 of these little operations that you need to do, then you can spin up actually 100,000 cores here, stick all these these little operations into those cores, and clean up when you're done essentially with all of these, and then tear down all these little processors at the end. And this is how elastic scalability kind of in Web 2 happens. And the end game for Web 3 is pretty much the same. Functionally, it's gonna kind of look identical. So let's say you have a transaction that requires essentially 10,000 different parts, or maybe there's even 10,000 different transactions. You can kind of, in the very beginning, look at the demand that you have, spin up infrastructure that you need kind of ad hoc to kind of service those transactions. You can schedule those transactions across all these different chains. Then you can kind of clean that up data backwise, and then you can shut down those chains ultimately. So now you have these like elastic Web3 infrastructure solutions that exist today. So what do you need to make this happen in Web3? Because obviously you don't have this right now, right? So the first thing you need is that developer paradigm shift, as I mentioned. So now developers are going to have to start thinking a little bit more about their applications in the horizontal sense, right? So they're going to have to change some of their actual programs to be able to support spreading out these operations across all these different chains. The second thing you need essentially is an asynchronous cross-chain communication protocol, because now you're no longer actually doing every operations in one chain, you're spreading them across all these different chains. So you need, for example, something like IBC that Cosmos uses, or other kinds of asynchronous cross-chain communication that requires you to spread out transactions across all these different chains ultimately. And the last thing you need is a new elastic infrastructure that allows you to spin up and tear down kind of chains on demand. And so this is what we're going to talk about today. So we're going to introduce Saga, and that's kind of exactly what Saga is. Saga is a chain, essentially, that launches chains on demand, ad hoc, in a permissionlessly automated and secure application deployment, essentially. So applications are launched on chainlets. So the mainnet of Saga doesn't do anything. All it does is it sits there and it receives transactions saying, hey, I would like to spin up a chain. And validators of the Saga chain are listening in on that chain and looking to see. And when they see that transaction to spin up a chain, they will spin up a second chain. We call them chainlets, and essentially secure them using interchain security. So, and interchain security is a concept that's in Cosmos that allows essentially you to borrow security from another chain. It almost works like EigenLayer's restaking protocol, essentially. And so what Saga does is it automates the manual process of actually launching these app chains, and it automates them, and you can kind of do that in pretty much seconds. So the Saga mainnet, as mentioned, is built on the Cosmos SDK and Tendermint core. It's essentially a chain. All it does is it receives transactions to launch these chainlets. And the nice thing about this is because we're using IBC for all the transactions, every little chainlets here are interoperable using IBC. And so Saga Chain supports launching, upgrading, and terminating of these chainlets. What are these chainlets? Chainlets are single-tenant VM blockchains. So essentially, it's a highly configurable way to launch kind of a different app chain. And so the first chain that we support is a Cosmos-based EVM chain. So any kind of EVM-compatible chain can launch a chain using Saga. But we can kind of expand this out into more different kinds of VMs different kinds of consensus algorithms. So we have a partnership with Polygon. We have a partnership with Avalanche to kind of automate the launching of subnets and supernets. We have a partnership with Celestia to kind of go into rollups. And we also have a partnership with Expo and Come to Us to kind of expand out their network ultimately. And so the idea here is that earlier we mentioned the kind of what is the infrastructure needed to make these elastic kind of blockchain launching. It's essentially Saga is a tool to do this effectively. So we have a test net right now. It's been going on for about 2 months. We've been kind of testing the capacity of how many chains we can launch automatically. Our team has kind of tried essentially launching 500 chains, and it took about a little less than an hour. So it's about a couple of seconds per blockchain. And each of the blockchains we have launched essentially get a dedicated RPC and block explorer that's fully available for everybody. We have about 200 projects that are kind of interested in building on top of Saga. We have an innovator program, which is essentially our ecosystem program. And most of the projects that we've actually been talking to has been gaming companies, because a lot of game companies want their own dedicated space to be able to support these kinds of things. But there are other kinds of, our platform is pretty general, so it can, anybody like DeFi, social, whatever kind of Web3 infrastructure can ultimately deploy on Saga. So let's do a quick summary. The idea is that you get commoditized dedicated block space. Everything is automatically interoperable using IBC. We have automated deployment and upgradability of these chainlets. You get dedicated chains with no dependencies on other applications, so you kind of get your own space. There's smooth end-user experience, and one of the things that we have is that there's no gas fees in Saga. So there's a lot of ways to do flexible monetization using any kind of tokens. That it can be the project's own token, it can be ETH, it can be USDC, it can be anything that the project wants ultimately. So we talked about this in terms of what is needed to get to the end state for Web3 in terms of infrastructure. And really, Saga is there to try to develop this kind of infrastructure. What cloud did and what AWS did for web infrastructure is something that essentially Saga is trying to replicate in the Web3 world so that we can have really good scalability ultimately. And so one of the things that we like to do essentially is be able to support all projects from the very beginning all the way to the end. So in the beginning stages, when projects are kind of testing and don't really have any customers, the fact that we can automatically in one click deploy a chain for you means that it's very convenient, and we would like to get essentially. And as they start getting adoption and get more kind of users, they can kind of experience low and predictable costs because of the way that our cost structure works ultimately. And then when they hit that growth stage, essentially, they can take advantage of the elastic scaling capabilities that allows them to essentially stand up as many chains as they want instantly. So now that we've talked about kind of the infrastructure and Saga, we introduced this a little bit, let's start talking about some of the fun things you can do using horizontal scalability. So one of the examples is, let's say, an NFT drop. So in Saga, essentially, you can kind of create an NFT minting platform that segments the NFTs based on different chains. So one thing you can do is, let's say there's Bored Ape, Yacht Club, and punks that are really popular. Essentially, you can spin up a chain that's just dedicated to those transactions ultimately. And then you essentially have a third chain that services all other kind of NFT transactions in there that are not those two. And let's say one day suddenly there's this game, we'll just call it Game 1, and Game 1 starts getting really, really popular and starts making the congestion in the other transaction bucket essentially. So then what you can do is you can kind of dynamically say, hey, I'm going to spin up this new chain that services Game 1, which is really fantastic. And the nice thing you can do with this property with horizontal scaling is that it doesn't have to be just one chain. Let's say, for example, you're expecting an NFT mint, and let's say there's going to be 100 million people coming in that wants to do an NFT mint one day. You just spin up essentially 100 different chainlets right now, service all the actual minting process for that, and then when the minting cycle is done, you have a lot less transactions, right? So you can shut down all these transactions over time. So let's say over time, Game 1 popularity goes down. You can actually clean up the actual state that you have in this chain that's dedicated to Game 1. You can compact it back into the other transaction section. Then you can tear down this infrastructure at the bottom so that you're no longer paying for this chain that you have at the bottom. And you can actually divide the actual use cases of blockchain horizontally like this in almost infinite numbers of ways. And we're just going to talk about a few, but this is just some brainstorming ideas of how Saga can be used to make transactions a lot more scalable. So here's a DeFi example. Let's say you have a bunch of these DEX transactions that are coming in. What you can do actually is start putting different pairs into individual chains. So you can spin up a chain that has ETH Uniswap, maybe that's because it's super popular. USDC ETH is another pair that's really popular, so you can kind of stick a bunch of those transactions in there. And you have a chain essentially that services every other pairs at the moment. And when, let's say, a new coin kind of has high in demand, you can spin up this new coin chain, maybe new USDT pair, and stick it in another chain. One of the things that that's a little bit difficult about this process is that you're going to have to migrate over some of the liquidity. But if this is something that you do not very frequently, this is something that's very possible, and you can kind of scale up your DEX application almost infinitely. And as the new transaction essentially, maybe new tokens are no longer that popular anymore, one day you can actually start cleaning up this operation, move all the liquidity back into the other pair section, and then tear down your actual chain. One more thing, let's see another parallel processing example. So in a game, let's say you have game players, and suddenly on day one, let's say you had 100 players, and so you could service them using one chain. But let's say tomorrow you get 10,000 players, right, or 1 million players, and suddenly that one chain can't really handle that use case. So what you do is you start geographically segmenting your users. So maybe the European users will go to a European chain. There'll be a Korean server, so Korean users will go and use that chain. And then you can essentially start spinning up multiple chains. So in here you can have United States 1 and United States 2, each spin up a chain essentially and try to service everybody that way. And maybe one day you'll notice that maybe the US players are no longer very interested in your game anymore. Then you can kind of compact that US chain essentially. You can move all the people from the US 2 chain back into the US 1 chain and then tear down that infrastructure so you don't have to pay for it anymore. So this kind of the ability to spin up and tear down these kinds of infrastructure on demand is something that you can use and it's a very powerful way to do so. There's other ways you can actually split up, and this is going to be one of the last ways I talk about. You can do functional unit segmentation, so you can have, let's say, a game chain that has all your game state. Then you have an NFT chain that essentially does the NFT minting. And then maybe you have a DEX chain that allows people to swap essentially items that you generate from those other chains. And so you can kind of start daisy chaining these kind of operations across different blockchains that you have, so that you're no longer essentially putting everything on a singular chain. So this is like one more way you can use to segment it and use horizontal scalability to make your actual applications much better. So that's kind of some interesting ways that you can use horizontal scalability and use Saga essentially to make your developer journey a little bit easier and a little bit more scalable. And this is a QR code just for our website, and it actually will take you to like a builder's website. So it's just a form. If you're building, we would love to kind of get to know you a little bit better and onboard you onto our actual testnet that's going on right now. So if you are, please join us in creating wonders together. Thank you.